So today we're going to start talking about roots. Our objective is going to be to find square roots of perfect squares and cube roots of perfect cubes. We are not using calculators for this unit at all, so all work should be done without them, but I will give you a handy reference guide. It's part of this presentation, and I already would have attached it to Classroom. It's the perfect square trail and the perfect cube list, and we will see those as we go through. So first of all, what is a square root? Well, a square root of a number is one of its two equal factors. And what that means is that if you take a number like 4 or 9 or 16, these are called perfect squares because there is 5 times 5. There's a pair of identical twins, two equal factors that multiply to 25. So 5 times 5, 4 times 4, 3 times 3. And these are perfect squares because their square roots are whole numbers, not a decimal, no fractions. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. These are all perfect squares. And the square root would be the 1, the 2, the 3, the 4, the 5, which is one of those identical twins that multiplies to give you this perfect square. Squaring a number and taking a square root are opposite operations. So if I took the number 4 and I raised it to the second power, remember we call that squaring, 4 squared would be 16. If I take the square root of 16, I get back to the 4. They undo each other, much like adding and subtracting undo each other and multiplying and dividing. Now, I need you to know that taking a square root does not mean to divide by 2. The square root of 25 isn't half of 25. So remember that it's undoing squaring. So this is kind of what they're trying to describe here, but the example is probably the best place to look. So if there's a number like 5 and you square it to get 25, then if you take the square root of 25, you get back to the 5. So squaring and square root are opposite operations. Every positive number has both a positive and a negative root. So the square root of 25 actually has two answers, positive 5 and negative 5. Because 5 times 5 gives you 25, that pair of identical twins, but also negative 5 times negative 5, that pair of identical twins also equal positive 25. Remember, a bad thing happening to a bad person is a good thing. So the square root of 25 actually has two roots, two answers, 5 and negative 5. So a positive root and a negative square root. Now the positive root also has another name, principal. The principal root is the positive root. You can remember that with the two P's. And this thing right here is called a radical sign. And when that radical sign doesn't have a number sitting in the V, it's an implied 2. It's a square root. It's looking for the square root. So anytime we are looking for a square root, we're looking for one of the pair of identical twins that multiplies to that number under the radical sign. So first of all, we need to kind of get a handle on what those perfect squares are for today. So basically, 1 squared, remember, isn't 1 times 2, it's 1 times 1. And 2 squared, 2 to the second power would be 2 times 2. And 3 squared would be 3 times 3. And basically, if you start to fill in this chart, right, you're going to come up with these blue numbers that are called perfect squares. So guys, what would be 4 squared? What would be 4 times 4? And what would be 5 squared? 5 times 5. Just pause the video for a second and look down the list and see if you can remember your multiplication facts and how far can you go here before you no longer know the answer without touching pencil, paper, or calculator. So pause the video a second and come back. Okay, so 4 squared is 16. 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 times 8, 64, 9 times 9, 81, and 10 squared is 100. I would expect everybody to be able to get there without a calculator and without paper and pencil. Now, as we get up in here, I know especially probably after 12 on, you might have some trouble, but you need to familiarize yourself with these perfect squares. So 11 times 11, all the way down to 20 times 20. These are all perfect squares. And of course, we're not done. It could be 21 squared. It could be 1,000 squared. Obviously, there's an infinite number of perfect squares. Now, another way to look at these perfect squares is to look at a multiplication chart, which I have on the next slide. And what I've done is I've highlighted down the diagonal. And as I've done that, those are your perfect squares. So the multiplication chart, if you took 6 times 6, that would be 36. This is 6 squared, 7 squared, 8 squared, all the way down to 20 squared. So that is your perfect squares. Now, when we're talking about taking a square root, we're no longer talking about taking 9 and squaring it. Now we're talking about what's the square root of 81. And now you're going to go back up, or if you prefer, over to the left, and the square root of 81 would be 9 or negative 9. There are two roots. The principal root would be 9, and the negative root would be negative 9. So here's an example. The square root is 64. So you could look back over at your multiplication chart. Here's 64. Come up. Do you see 8? So it would be 8 or negative 8. Now your book will use a convention that if they don't put anything in front, they want just the positive. If they put a negative in front, they want just the negative root. And if they put the plus or minus, they want both. So that's going to be the convention. Now look over here. Wait a minute, Mrs. Woodruff. 1.21 is not on the perfect square trail, but 121 is. So the square root of 121 would have been 11, but we kind of stuck a decimal in there. Is it possible without a calculator, we could figure that out? And the answer is yes. It would be, again, plus or minus, because they put it out in front. We're going to get both roots, the positive and the negative. And do you see the 11? But we kind of inserted that decimal back in. So if there are two decimal places when you're taking a square root, there'll be 1 in your answer. So if you took 1.1 times 1.1, it would equal 1.21. So the square root of 1.21 is 1.1, and we can kind of guess that by using our perfect square trail. Whoa, wait a minute, what's this? Well, before you go anywhere, do you see a perfect square on top of another perfect square? Remember the 25 and 36. Do you see there's the 25 and there's the 36. The square root of 25 is 5. The square root of 36 is 6. So we can kind of cut that square root across this division and take the square root of the top over the square root of the bottom. Where did this negative come from? They want only the negative root. Now, finally, here's the weird one. 16 is a perfect square, but not negative 16. What number times its identical twin gives you 16? Well, negative 4 times negative 4 would be a positive 16. And 4 times 4 is positive 16. There is no pair of identical twins, but Mrs. Woodruff, negative 4 times 4, they're not identical. One's positive, one's negative. So if you see the negative under the square root, not outside, but under it, this is impossible. And I know I told you not to use your calculator, but at some point we will take a square root of a negative, and I'll show you how the calculator kind of blows up with an error message, okay? So you cannot have a square root of negative. You can just say no solution, and you'll notice they say no real number. Okay, no real solution. So here's a chance for you to just see if you can try this. I'm going to ask you to pause the video. Remember, I have attached that multiplication chart with the perfect square trails at Google Classroom. You can also back up right now because there hasn't been a question asked, and you can check that out to answer these 4 questions. When you're set, come back, please, and we will continue on. Okay, so here is that fraction look, but look, you got a perfect square on top of a perfect square. Square root of 9 is 3, and the square root of 16 is 4. So it's 3/4, and the book only wants the positive root. Did you get 3 over 4? The number one mistake would be to try to cut these in half. Okay, remember, the square root is not dividing by 2. It's what number times its identical twin equals the number under the radical sign. Okay, so the book wants both plus and minus here. Ooh, 81. Yeah, the square root of 81 would be 9. Oh, but there's a decimal. Mrs. would have said if there's 2 decimals in that question underneath the radical, then there would be one decimal after the one number after the decimal in my answer. So did you put plus or minus 0.9? Oh, by the way, 0.9 times 0.9 will give you 0.81 because there'll be 2 decimal places. All right, oh, the negative's on the outside. Okay, so they only want the negative root. And the square root of 49, what number times itself equals 49? 7. So this would be negative 7. Ooh, it's a square root with a negative. There is no pair of identical twins, the exact same numbers that multiply to negative 100. So this would be a no real solution or no solution. So that's how we find square roots of perfect squares. So this is just an equation, and it's really just asking you the same thing. It's saying there's some number, t, some number, I don't know what it is, but when I square it, I get 169, and they want to know what t is. What number times itself gives you 169? So that is asking you to figure out what the square root of 169 is. So we would come back to our perfect square trail. We'd find 169. We'd come up, and it's 13. Now this question, because it's not able to kind of tell you whether it wants the plus or minus or the negative or the positive, this you would give both solutions as part of your answer. So if you take 13 and square it, you'll get 169. And if you take negative 13, remember in the gloves, in the parentheses and square it, you'll get 169. So the way you would write your answer is t equals 13 and negative 13. And I'm actually okay if you wrote t equals plus or minus 13. That's the same way. So now here is 3 sort of the same type of things. You're going to, down here, you're going to have a equals, and you're going to give me both roots. So see if you can pause the video and try these 3, please. Again, no calculator, but you're welcome to use the perfect square trail. All right, so I'm going to go back looking for 289 on the perfect square trail. Oh, right there. Come up. It's 17. So what number squared gives you 289? 17 or negative 17. And you should write it as an equation. Since it was given to you as equation, you're going to give it back. And if you have this switched and have plus or minus 17 equals a, that's the same equation. Oh, it's a decimal in there. Well, the square root of 9 would have been 3, but since there's 2 decimal places, I'm going to have 1 decimal place in my answer, and I'm going to give both roots, the positive and the negative. So m would equal plus or minus 0.3. If you take 0.3 times itself, you'll get 0.09. And finally, I'm not going to get all freaked out by this fraction looking thing because there's a perfect square on top of a perfect square. So again, I'm going to give y equals, and I'm going to give both roots. I like to write it plus or minus because I'm lazy. It saves me time. Square root of 4 is 2 because 2 squared equals 4. Square root of 25 is 5 because 5 squared equals 25. But I'm going to give both roots, and it will be a fraction. So if I take 2/5 times 2/5, I'll get 4/25. And if I take negative 2/5 times negative 2/5, I will also get 4/25. So one application of this is area of a square. So normally I would have given you a side of the square and asked you to find the area. But now that you're 8th graders and you understand roots, I'm going to give you the backwards problem. I'm going to give you the area, and you're going to tell me what the length of one of the sides is. Actually, you're going to tell me what the perimeter is. So let's first get one side, and then we'll figure out what that word means. So if I was to find the area of a square, I would have taken one side times itself. I would have taken a side squared. So to get back to it, I have to do the opposite operation, which is to take the square root. So we're going to go back to our perfect square trail, looking for 361. It's way down here. And if I go up, you see that it's 19. So the square root of 361 would be 19. Now, I'm not going to talk about the negative because that wouldn't make any sense. You can't have the side of a square be a negative number. So it would be 19, and this time I'm going to put my inches in, so it would be 19 inches. But that's not what the question asked. It asked for the perimeter. Do you remember what perimeter is? The perimeter is all the distance around. Just like if you were going to put fencing all the way around, you would need 4 of the sides, 4 lengths of sides in order to kind of totally fence this in. So if I have one side, I need 4 of these. So 19 times 4, I would need 76 inches of fence, which is crazy if you think about fencing. But okay, just before we move on, we're going to do one change here. Let's just see if we can't take a look at these 3 together, just as a kind of a wrap up on square roots. Do you see 1.44? But if I take the decimal out, that's 144. If I go back to my perfect square trail again, looking for 144, I noticed that it would be 12. But it had a decimal in there. Remember the 2 decimal thing? I said if there were 2 decimals, then there would be 1 in my answer. So I'm not going to put 12 here. I'm going to put 1.2. And again, if it's not showing anything out in front, you give just the positive. Holy cow, that's way bigger than my perfect square trail. 196 though, wait a minute. 196 sounds familiar. And oh, look, 196 would have been 14, but I put 2 zeros on the end. So 14 times 14 gives me 196. Can I use that to figure out what this would be? So maybe it's not 14, but what about 140 times 140? Sure enough, that would be the square root of 19,600. So we can even use these perfect squares if we see them hiding in bigger numbers to possibly get those roots. And again, where'd the negative come from? Because it was out in front here. And then one more here. Don't forget, if you have a fraction, if these are both perfect squares on the perfect square trail, you just take the square of the numerator, the square of the denominator. This one wanted plus or minus. Square root of 225 is 15, and 289 is 17. And that's kind of how we find square roots of perfect squares. So I'm just going to change your thinking just a little bit here and talk about the fact that there's not just square roots. There could be cubed roots. In algebra, we even do 4th roots and 5th roots. And don't worry about that. But we are going to talk about cube roots. So cube roots wouldn't be identical twins. It would be identical triplets. So a perfect cube is a number like 8 or 27 or 64. 8 is 2 to the third. 2 times 2 times 2. Do you see the perfect triplets right there? See the identical triplets? And 27 is 3 times 3 times 3. Not 9, but 3 times 3 is 9 times 3 is 27. So this is 3 to the third, and this is 4 to the third, and these are called perfect cubes. So now when I take the cubed root of a perfect cube, I am looking for one of the identical twins that multiplies for 3 factors to give you that number. So this is the symbol that is a cube root. So it's that same radical, but notice a little 3 dropped in the V. So when there is no number in the V, we assume a 2, we assume a square root, we assume identical twins. If there's a 3, that's a third root, and now we're looking for identical triplets. So taking the cubed root is the opposite of raising something to the third power, of cubing it. Now, the first thing we need to do is come up with our list. I'm not going to give you a perfect cube. There's no perfect cube a trail like on the multiplication chart. So we kind of just have to come up with a list. And we're really just going to work with these because you're going to see why in a second. So please remember that this is not 3. It's 1 times 1 times 1, which is 1. And 2 times 2 is 4 times 2 is 8, right? And 3 times 3 is 9 times 3 is 27. And 4 times 4 times 4 is 64. I'm going to do one more here. 5 times 5 is 25 times 5. And look how big they're getting. So the bigger this exponent, before we had 2 for squares, now we have 3, it grows really much faster. Look what's happening. Remember that 10 squared was 100, and 10 to the third is all the way up to 1,000. I'm going to give you the rest, and I'm going to let you know that this is also part of a reference sheet that I would have attached to Google Classroom. We're not using our calculators, but you are welcome to have this out for quizzes, tests, and also for any work you're doing with cubed roots. But look at 20 squared was 400. 20 to the third is 8,000. This is what we called exponential growth, things growing really rapidly. We're involved in a pandemic right now, and a virus. And you can see, you heard people talking about flattening the curve. Well, the bigger that exponent is, look how fast things are growing. So you want that exponent to be small. If it's smaller, it grows much slower pace. So we're going to use this as our reference guide. And all of these, 1, 8, 27, 64, they are perfect cubes. So now the first thing I need to tell you is that when you try to take the square root of a negative, that's a no-go. There are no identical twins. However, when you try to take a cubed root of a negative, there is a number. Because a negative times a negative, a bad thing happened to a bad person would be a good thing. And a good thing happening to a bad person would be a bad thing. So we actually, the negative 3 times negative 3 times negative 3 does give me negative 27. So the cubed root of negative 27 does have an identical triplet. It's negative 3. So we're never going to see with cubed roots a plus or minus. You're going to see either a positive or a negative, no plus or minus, and there's no, oh, it can't happen. There's no solution. So cubed root, get your eye there. So we're not going to look at that multiplication chart. We're not going to look at the perfect square trail. We're going to go back to our list of perfect cubes. And you see 125. So you look over here, 5 would be the cubed root of 125. And you're only going to put positive. Now here, do you see the cubed root of negative 27? If you see a cubed root of a negative, it's going to be a negative answer. If you see a cubed root of a positive, it's going to be a positive. And this, again, if you go back to our perfect cube list, there's the 27, and it would have been 3. So how about your turn? Can you pause the video? And again, you can back it up to see that list right now, or as a reference guide, it's on Google Classroom as well. Pause and see if you can do these 3, please. No calculators, just using your perfect cubed list. All right, we need 729, 64, and 1,000. Remember those. 729 would be 9. 64 would be 4. And what's the last one? 1,000. And 1,000 would be 10. So cubed root of 729, positive 9. Cubed root of negative 64. Don't put no solution. There can be identical twins. It would be negative 4. And the cubed root of 1,000, positive 10. And that's how easy it is to find cubed roots. So, where do we use that? Here's an example of an equation. Dylan has a planter in the shape of a cube, and it holds 8 cubic feet of potting soil. Now, that's not the area. That's the volume. That's how much soil goes inside the cube, the box. This is your equation. So to find one of those sides of the cube, you take the volume and you take the cubed root. So we need the cubed root of 8. So again, just to show you, if you come back here, cubed root of 8, it's 2. 2 to the third. So 2 would be one of the identical triplets that when you cubed it, you would get 8. So notice they got an answer of 2. And don't forget to put your units. And they told us up here it holds cubic feet, so your answer would be feet. Not square feet, that would be area. Not cubic feet, that would be volume. The length of one of the sides would be 2 feet, straight measurements. So here's a chance for you. This is our last problem. We've got an aquarium. Actually, let's do this one together. And we'll see, see how it goes from here. Aquarium in the shape of a cube will hold 25 gallons of water, and it has a volume of 3.375 cubic feet. We're going to use this equation to find the length of one side of the aquarium. And the reason I stopped and said I wanted to talk to you about this one is lots of times in a word problem, kids want to use every number here. The 25 gallons right now in this problem is kind of extraneous. It's extra information. All we need to do right now is this is the volume in cubic feet, and we're looking for one of the sides. So we're going to undo cubing by taking the cubed root. 3375, there's a decimal. Let's worry about the decimal in a minute, but let's go back looking for 3375. Do you see it? So if it had been 3,375, the answer would have been 15. But remember, there's a decimal in here. And now, since we're doing cubic, no longer would, we look at 2, we're looking at 3 places. So if your cube has 3 places, your answer would have 1 because of it being cubic. So you're going to have 1 decimal place in your answer. So we're going to stick the decimal in between the 15 is going to become 1.5. If you took 1.5 times 1.5 times 1.5, you would end up with 3.375. So if there's 3 decimal places for a cube, then your answer, taking the cubed root, will have 1 because of dividing that by 3. So we've done square roots of perfect squares, and we have done cube roots of perfect cubes. And we've also seen how we can use those perfect squares and perfect cubes to answer some other answers that have decimals or fractions in them as well. So guys, it's time for you to practice. So have a great day, and everything is square roots and cube roots today.